I want to start the discussion from this panel with Mr. Razvan Coban, global leader for cybersecurity activities conducted within PREH company in Romania. Mr. Coban has an experience in software development technologies and engineering with more than 12 years of experience in automotive sector within several companies in Romania, especially and engineering and cybersecurity. Today he will talk briefly about the impact of the new regulation of cybersecurity in automotive sector. Mr. Coban, you have the floor, please. Thank you very much for the invitation, for having the opportunity to be here together with my colleagues. In the next moments, we will talk about a new component or an unexplored area in the recent years. The cybersecurity and automotive, it starts to be felt in the now at the moment from now on, and I will tell you about components that we develop for cars, and that's a new point that comes alongside with processes and new rules, but also it has some constraints in terms of us developing the design of our products. Well, let's start with the first point. We talk about piracy or hacking. This part from the 90s, but the stake was not so high that moment, or we did not target us directly. Well, there were those cards for satellite that were prepaid or paid, and there maybe were some programs or matches that needed to be might be watched on based on cards. So that was the interest of hackers, to get access to something that was paid. They wanted to get access to those programs. That's why they started to hack them. Next, they focused on from satellite and TV. They focused on cards, FIDs or contactless cards for paying transportation costs. Well, the stake was higher now, but the element behind this was the same. The idea was the same: how to get access to something that I don't want to pay for. Next, we had an intermediate period about 2010, when they started to raise the interest for the academic sector. And there were people that had good interests, like the white hacking part. They found the vulnerabilities, and they informed this industry, the sector, about the vulnerabilities in order to improve. This was an intermediate stage, and one which made these companies, the firms, to get closer to the academia, to the university sector. As of today, the situation has some kind exploded, extended, and we see nowadays attacks on automotive sector, vehicle producer, manufacturers, and components. I want to say that there is no meaning to compare that X manufacturer is safer than Y manufacturer. It depends on what measures to protect themselves they took, and to what extent the attacker might be interested in that product. It's not meaning to use 5 years to hack a system for a car that will be outdated in a few years. So day by day we have new information that would scratch the surface firstly, and they get at the top with conferences, and we get to responsible disclosures with OEMX. Well, there are also ideas or moments when they pay these people to hack a product. So we pay you, you get an award, but please tell us what did you do and how did you get to there in order to improve our product. Well, we talk now about those who had contracts with automotive sector. There were a lot of discussion about safety or functional safety. And the next slide, I would like to have a kind of a parallel, because they have some joint points, but from a specific moment they start separating. So let's start with the safety. In that sense, we talk about protecting the person, the individual, from a system that is not functioning according to the required parameters. So we have a person, and the attacker would be the system, but it's not voluntary; it's intentional. The system is not intended by itself to press the not to press the brake or choose the brake, but that it does happen. So it's a few years that we have this standard that applies in this sense. But next we talk about cybersecurity, and the perspective changes a little bit because we want to protect the appearance of the intentional events. So there is the attempt to prevent the systems attacking the environment, the person, by limiting the risk of attacks caused by humans. And we have a break in the chain because there are persons that want to attack or threaten an embedded system having a purpose, and the worst scenario would be with having the intention to harm other people. So we could not protect ourselves if something is intended, and this might work in the end. At the beginning, we have a classic case. You take out the component, you disassemble it, take the case out, and try to understand what the author wanted to say. It's part withdrawal from the vehicle and reverse engineering. Then we start to have access to interfaces because we try to get traffic and to interpret these elements. Next, we start to have access to wireless modules, and in the end, we'd like to have a connection to the backend servers of the original equipment manufacturers from the respective producer. And in that sense, the highest the stake, the highest the payment, the result. But the final result is that the attackers want to find the middle way, lowest effort and highest results. So if you look at the slide, it's very hard to get to the back end of an OEM. This thing could not remain just without being addressed, so we had to establish some limitations, some constraints. So we have three such documents. We have a standard, another standard of quality, and the EU regulatory document. All the three elements manage or regulate the way we are doing management of systems for cybersecurity risks. And this is disaggregating several pieces, and you'll see that next it focuses on the organization management, how this is structured, culture, governance, competencies, and the way you treat the security aspect as a whole, the way the projects are managed, also the way we monitor the activities that we put on the market, the product development, but also we focus on post-development monitoring. And mainly that's the procedural element. Next we'll see some more technical aspects. Maybe they would raise some interests because these were not explored. And I'd like to start with data at rest, which are fixed in the controller, in the software. And in that sense, we use microcontrollers that compared to the classical setup that where we had the 3 or 4 cores with the same flash memory, we have microcontrollers with security areas where they have a trusted area and with their own memory, internal memory, and this memory is not accessible from the outside, and on that memory we store all the sensitive materials that we don't want to have outsourced from this. And this changes the perspective of cost and also the way we design what to put and where to put, how data are stored. Do we want them public or we want to have them only for us? That's the first component. When we talk about the soft directly, here the digital signature or digital certificate, it exists in the other in the sectors. We take it over in automotive, and it serves as a way to check that the soft that is to be programmed is a really authentic one. It's the one we need. And the classical use case, when we have the output from compilation, we pass it from a hash function, we crypt it, and we check it using the digital signature at the other end. You can see there are similar approaches like in other sectors, cloud, storage, secure databases, and so on. We try to bring this to automotive. This brings some complexity and some time and cost related elements. Now let's talk about data in transit. You know that inside the car we have several components that communicate with each other. Next, they could communicate with the outside environment when we go to a car service and we do a diagnostics. And that case, the car talks with the computer. So the module that we developed, there actually is no identification number. So what we should protect is that basically everything that we use in that system or everything that could affect the functional safety. How do we do this? We develop a combination between signature and firewalls. So we have a message that is conveyed, we send some data, we add operations which are in hand, maybe counter or other values, other algorithms. We crypt them or calculate in MAC, and the result goes in the end of the message. So I send some message with a signature. There is at the reception when the person receives it, we check this, and if the check is good, I'll have access to it. Otherwise, everything will be deleted. And basically, we have here the firewall mechanism that is put in the game. And last but not least, there's another important aspect affecting us very well in terms of authorization and authentication. And in that case, we need to make sure that only the persons or entities that are needed to have access to those resources. Basically, behind every diagnostic, we will have an authentication of the user, of the person in the database of the client. And according to their credential and the level of access, they will be able to conduct more or less activities. And in that regard, we have other elements from other industries, double factor authentication, fingerprints, user-based certificates, mechanism that exists in the IT for years. We start bringing them in the embedded sector. But the difference is that in embedded, we don't have 4 giga from RAM or flash. So we need to do this in a very super optimized way. So everything that I told you, it's only the peak, the top of the iceberg, but there are other intangible, unseen elements like security penetration testing, the way we manage the vulnerability, the way we manage the fleet of vehicles. Well, we have 1,000 vehicles in the same fleet with the same software to understand if the same issue or different, the way we respond to different issues, incidents, and the way we update the software. And more important, in terms of updates over the year compared to the Android, we don't have to the mobile communication. We don't have the luxury to use the Android systems. In that case, if we are in a tunnel or in a no signal area, we need to have a mechanism that when we go back to the previous mechanism, because we cannot take the car from the top of the mountain to be taken to a platform. Basically, this affects us, but these are elements from the industry that the automotive is willing to accept and to take over. To conclude, I say that there is a long path to this moment. It's a not explored area. It's full of potential, but it's clear that this security is not longer an extra option. It becomes the default. And basically, this helps the users, the customers, those who buy the cars to meet the security and trust standards. That was all from my side. Thank you very much for your attention. Mr. Coban, thank you very much for your presentation, and following the speech you've had, I would dare to ask you 4 questions. And the first would be, what impact would have a security breach in terms of the trust of the customers in relation to the use of the vehicles? Obviously, the impact is a very big one, because if we talk at the Maslow's pyramid of needs, basically a security breach or any element that decreases the trust in that product affects the second layer, the safety and security layer. in relation to the own person. The low level of trust of the customer leads to a damage of the image for the manufacturer of that vehicle. Every image damage brings financial damages, and this goes like an avalanche. It increases in dimensions, and nobody wants to be part of this avalanche. That's why most of manufacturers and suppliers try to do their best to implement all these mechanisms in a way that it never gets the moment. Well, we never can be 100% secure, but we could tell that we are as secure as possible with our technology. What role do the standards play in ensuring cybersecurity in automotive sector? First of all, I'd say that this establishes a specific environment and sets some limits that everybody should adhere, should respect. No, there is no space for interpretation of some clauses. No, everybody should implement the same things, the same standards, regardless of the fact you are BMW or Ford. The core is the same. Plus, this will help building your image on the market. Do you take more measures than is needed? You pay more importance to the fact, and this leads to a higher trust in relation to you. Well, thank you very much for everything you do in terms of ensuring cybersecurity in automotive sector. Now we continue to discuss about this topic, and we will continue with the intervention of Mr. Eugeniu Munteanu from AROBS Software company focused on developing solutions and software services for clients. Mr. Munteanu has been working for more than 20 years in developing different products in automotive sector, and he will tell about his expertise in AROBS software in this field. Mr. Munteanu, please, you have the floor. Good morning. I am Eugeniu Munteanu from AROBS, the branch in Chișinău, and I will present shortly the achievements of AROBS software company in embedded sector, especially automotive. Well, AROBS company is a lead company in software and services sector. It has offices and branches at the local and international level, more than 1,300 employees and collaborators, about 70 partners of the software services, Europe and America, and more than 11,000 customers for the software products business lines in Europe and Asia. We have won different awards in Romania, and for 2023 we have a turnover of 85.8 million euro. The motto of AROBS culture, our company is European by birth, international by culture, and this is referred to the fact that we have 11 offices in Romania and 10 international branches in different countries in Germany, UK, Netherlands, Belgium, and including Moldova. AROBS recently has joined the Bucharest Stock Exchange, and AROBS is the largest technical Romanian company that is present on the Bucharest stock market, and this is one of the few largest companies offering this so-called free employee stock option plan, according to which every employee of the company can also become a partner when they buy some or own some shares. We might tell that AROBS has reached the global level in terms of providing IT solutions, providing ready-to-use systems based on the latest technologies. We have more than 25 years of experience in software services, and we are oriented towards different IT needs of different industries like automotive, embedded systems, travel, medicine, hospitality, and so on and so forth. Our background and expertise relies on experiences in the embedded system focused on different narrowed systems like embedded for automotive, industrial IoT, medical devices, aerospace, maritime, marine technologies, and so on. What do we have here for automotive? We provide customized solutions, software, hardware, and mechanical solutions for a wide range of automotive products. Our specialists develop different projects and take part in the design of this development of these projects at all levels, starting from the basic software with the development of different device drivers, middleware components, even applications. Basically, they are involved at all levels of the product development. Therefore, we have experience in terms of different architectures or strategy, OEM strategies. Sorry. We have more than 15 years of experience in automotive and embedded system sectors. We have a quite extended international team of professionals. We work with different countries like Romania, Germany, France, China, Japan, and many others. And in 2021, we received the title from Continental Company as the Supplier of the Year for the engineering services. This award was due to the fact that our manufacturers, our teams were involved basically in all the sectors or in the development of all components you could find in a car. Now we'd like to talk a little bit about the internal structure of company for automotive and embedded system sector. We have two groups in this regard focused on body and security, access systems, ADAS, multimedia, telematics, powertrain, gateways, instrumentation, and tool sets, different kinds of tool sets and instrumentation. And in group two, we have instrument and clusters, display, engineering systems, and so on. As I've said, AROBS is looking more at developing software solutions, and we have cooperation with different companies. But we also have some smaller interior projects. If we talk about electric vehicles, we have a project related to EV chargers. This project implies the development for hardware side chargers with 11 or 22 kilowatt for chargers for type 2 connectivity electrical vehicles, long charging cable of 7.5 meters, integrated meter for current power, and different channels of communication. And the software part loads over-the-air updates, remote control for pre-mod bus or OCCP protocol, plug-and start elements, power allocation, surplus charging, so that we have it integrated in a grid or network that would imply the use of solar panels, power distribution or load management, start-stop charging module, and mobile app support. We also have a point on connectivity to a cloud backend. In order to bring you an overview of our experience, we have a high expertise in automotive and autonomous vehicles. We are certified according to TISAX AL2. We are partners with ACEM, Association of Electronics Companies in Moldova, and the main projects in this sense are advanced lighting technologies, which uses LED arrays and video cameras to detect objects and vehicles around the car in order to automatically adopt the headlights. And we have also a cluster of digital tools or to bring analog displays on information related to the vehicle or around the vehicle. That was all from my side. Thank you. Thank you very much, Mr. Munteanu. After your presentation, I would like to have a clarification for those who are present today. And I would like to ask, how difficult is it for embedded product developers in the automotive sector to have a balance between the performance of the vehicles and the safety measures? Safety is something that we are probably most interested in when we buy a vehicle. Recently, I've been working in the area of safety. And for me, of course, safety has the highest priority. I would say that the most important aspect is to follow the standards. This is something relatively abstract, but it has a long-term impact in the product. Discussing about automotive or embedded systems, the biggest issue is the fact that the developer or the company that supplied a product cannot step in immediately to fix a problem. For example, for web products, like in the web products. So here, the situation is a bit more complicated. The supplier, beside the fact that they have to have a standard like ISO 26262 that they follow, they need to take responsibility on the long term that this product will not endanger the life of persons. Yes, the functionality of the device or the car itself is also important, but I would say that what's most important is following the standards and accountability in developing the product from the point of view of the security. Thank you very much, Mr. Munteanu, for your intervention. I would like to say that AROBS is a partner of the Technical University of Moldova for the implementation of classes for embedded in automotive. And Mr. Munteanu is a lecturer in the Technical University of Moldova, and would like to congratulate your partnership in this area. Dear audience, now we have an intervention from Igor Railean, developer from BSW Tech. He has experience in cybersecurity and automotive. He has developed different projects for the companies in Romania and Germany. Mr. Railean will tell us about the expertise of the company BSW in the implementation of security project. Good morning, everyone. I would say that this panel should be called Safety in Automotive because we are all discussing about safety. My name is Igor and I'm a member of the BCV Tech team. This is one of the few companies in the Republic of Moldova that are doing outsourcing in the area of automotive. I have 8 years experience in embedded automotive. I used to work as a safety engineer in functional safety team in automotive. And I would like to tell you a bit about what we have been doing and what I have learned. What is functional safety? As my colleague from PREH mentioned, functional safety is part of what we call safety for cars, for an electronic control unit. Each control unit from the car should respect ISO 26262. Why? Because functional safety aims to reduce the risk to have injuries or even deadly injuries for the users of the car, but also for other participants in road traffic.
And currently, users don't like reading product specifications, especially in automotive. And the system needs to protect the system from the user from the system and the system from the user. And I'll give you a simple example from electric cars, because not everyone knows how to connect the charger to the car. And it's interesting to see what happens to the terminals when we switch them on or off. The safety measures take care of the fact that make sure that the user is not electrocuted or doesn't have any burns and other injuries. I have mentioned the most important reasons why producers should follow ISO 26262 very strictly. For example, the use of internet in the car. For us, today the car is like a smartphone, and we like not getting out of our comfort zone when driving. We want to have access to online maps. Sometimes we watch YouTube or we access something within the car without using the phone. And here we have a high risk mentioned by our colleague from PREH. This is cyber attacks. We in functional safety are lower than cybersecurity, and we are somehow protected by cybersecurity, but we cannot be sure that all protocols or keys are well protected, and that tomorrow there will not be a technology that will corrupt this data and that will affect us. So we need to take this risk and to protect the user from the danger that could arise if the system fails. And the second aspect is advanced technologies. And I'll give you a short example. Today, the car is not just an engine on wheels, so whether this is an electric engine or a combustion engine, we are not only looking at the engine, but also at the technologies implemented in the car. People are interested in security, radars, ADAS, assistance for parking, cameras, and other devices that are part of a modern car. And all this technology has the risk of being corrupted, of failing, because we do not have perfect systems nowadays. And I'm coming back to ISO 26262. This ISO standard regulates the interaction between software and hardware at the lowest level. It needs to ensure collaboration for the software at the lowest level. This means that the software needs to maintain hardware working all the time, and if there are any issues caused by the system or by the user, it needs to maintain a safe state where it does not cause or does not lead to any risk for the user or for other participants to the road traffic. And there is safety measures that is used at the level of basic software, and we are obliged to use it because our module, our controller, has received a several level of integrity. We should know that ISO 26262 does not tell us how to implement a certain security mechanism, does not tell us how the algorithm works or how we should write the code. It just says that this system has a high risk of causing damage, and we should implement this mechanism. And I'll give you an example. We have RAM memory where we store the binary code executed by the electrical control unit. We have built-in mechanism for the microcontroller, like error correction code. We have a memory protection unit, So we restrict access to this area of memory that we consider to be related to safety. And we all know that ICUs communicate among themselves in the car through basocam. So we can monitor important messages through an end-to-end protection technology. And again, this is not mentioned in ISO 26262. It only says that we need to use it. What is important in 26262 is a SAIL, Automotive Safety Integrity Level. This is a scale to classify ICUs by the risk level. And the lowest risk is A and the highest is D. So high risk cell is airbag, ABS, and A level SL risk will be the charger for electric vehicles. How is this classification done in ISO 26262? We have the exposure probability, the controllability by driver, and severity of failure. And the sum of all these aspects gives us the SL for the controller we are developing. And now I will show you a diagram. It seems it has a lot of information, but I hope it is clear. This analysis is done at the beginning of the development of a product. It shows us what level of SL our product will have. And we have the three aspects. And let's analyze the last row in the table on the right, because there we have a module with the highest level of risk, SLD. And we can see that the severity is S3. This means that in case of a failure of the system, we can have life-threatening injuries for the passenger or the driver. This means that the exposure to this risk is very high, and C1, C3 controllability, this does not mean anything because the driver cannot control this process. So such a system is the airbag or the ABS. So the driver is confident that the system is working, and once they press the brake, they expect the car to slow down. And we categorize this as SLD. I, as a software developer, understand that I need to implement the highest number of security mechanisms that I know about or that exist at that moment. And I will tell you about the phases of product development from the safety perspective. There are three phases that each software goes through. In the concept phase, we have a HARA analysis, hazard analysis and risk assessment. And this is very important because this is where we determine the integrity level for the module we are developing. Also, we need to develop the safety objectives or goals. What are safety goals? Shows us what risks can arise during the functioning of our module. For example, electrocution or burns. And after we have the HARA analysis, we have this document that is developed, safety concept, where we describe all the use cases that are potential. And these are analyzed to create requirements that are then implemented by the safety engineer. The concept part is developed by the manager together with the customer, because sometimes if there are constraints, the customer needs to understand that safety might not allow the implementation of certain features. So after we have all the safety documents developed, I only mentioned the safety concept because this is a document that goes to the safety engineer and throughout the development of the software. Then in the product development phase, we have the technical safety concept. But the safety software goes through the same steps as a simple software in automotive. We have the same recycle and VSPICE standards. The exception is that in order to validate a safety code, we have safety analysis, safety qualification, and the safety concept that is all updated all the time. So when we are developing a product, we might understand that there is another use case where our system doesn't know how to react. But since we have an unpredictable situation, the system goes to the safety state. This is a state when it cannot lead to injuries. In conclusion, security goes hand in hand with advanced technologies. Whether we like it or not, this happens. And the fact that we have internet in the car makes the car an open system, interconnected with other internet systems. These systems could have access to the car and could corrupt the data. The hard system that is working daily because it is doing the most of the work needs to be protected. If we have cybersecurity, we know that we have ISO 26262 that will take over control and will maintain security in our car. Thank you. Thank you very much, Mr. Railean. This is a very interesting presentation, in my opinion. Out of curiosity, I would like to understand what are the challenges for an engineer when you implement cybersecurity, when you develop the security aspects. For me, the most challenging part is the interaction with safety experts and with the managers from the highest level of development. I took part in the revision of the safety concept, in the safety requirements, and I like the fact that this field is new and is open. You can always find a use case when it seems like this cannot happen. So you could find use case, and it is approached by the highest level of safety experts. These cases are thoroughly analyzed. And yes, the activity in a new field is always interesting and challenging. Thank you, Mr. Railean. Now we have with us Mr. Nicolai Gritco, who is the founder and manager of Quasar development that is using AutoSAR development and auto tools, also artificial intelligence. They are offering software solutions of high quality to German manufacturers in the automotive sector. Thank you, Elena, for the presentation. Good morning, everyone. I'm honored to be here today together with our colleagues from the industry, and I would like to thank the organizers for the opportunity to share with you the experience and expertise of Quasar development. Maybe you are asking yourself, what is Quasar? This started when I was in university, when I was passionate about IT, physics, and so on. During the next 10 years, I developed my engineering and management abilities, and I always wanted to develop the development of this area. Therefore, in 2022, together with a colleague, I started Quasar development. And in my opinion, in 2 years, it managed to have remarkable results. We have 9 employees. We have 5 projects in production, 1 project that is developed 100% in our company, and 3 partners from Germany and Austria who are supporting us throughout this journey. Quasar Development is a company that specializes in offering consultancy and software development services. Now we have four directions we are focused on: development and testing in automotive, tool development, project management, and artificial intelligence. Today I will tell you more about the first two directions, because initially we wanted to only have software development services. But as time goes by, the requirements from the customers became more complex and we had to adapt. Therefore, today we are able to offer a complex package of services that has all services from the creation of the requirement up to testing. Up to now, we have mostly used in battery management systems, heating systems, airbags, bootloaders, and so on. But as you can see, the potential of our team is higher, and we could take part in the development of any project in automotive. I will tell you a bit about my professional experience. Since my first job, I had this frustration um, caused by tasks that took a lot of time but did not teach us anything new. So I thought about automatizing these tasks. In Quasar, we took over these results. We are not just developing software, we are improving efficiency and productivity. Today, we will present three tools developed in Quasar development. The first is flashing tool. This is a tool that can program different microcontrollers and run tests for bootloaders. The second is report gen. It is a tool for report generation and graphic generation based on inputs from Power BI and IAMS. And the third one is the ECU simulator. This is a tool that can run and test projects based on AutoSAR architecture. Did you know that in approximately 30% of projects it can have hardware delays due to different reasons? We also face this issue, and we had to start our project 3 months later. This made us start the development of a simulator that would allow us to be more independent from the hardware part. After 6 months of development, we had this simulator that later became the visit card of the business card of our company. Let's look at the functionalities. This is a tool that can run projects with AutoSAR architecture without having an ECU and card case. We can import different files such as CDD, as you can see in the image RXML. We can test different functionalities, and we can do this in a free development environment such as Studio Code. We can interact with instruments from Vector such as Canoe and Canape. So we are running the project directly in the simulator, and then we have the tests in Canoe. We can simulate PVM, ADC, we can simulate ports and other functionalities that are vital when you don't have hardware at hand. Our simulator is easy to integrate in an AutoSAR project, and the functionalities that would expand this tool are limited only by our imagination or the requirements of the customer. In this industry, discipline, curiosity, and courage are important. These are the qualities that are needed to innovate. The qualities of our team are reflected in Albert Einstein's words. I don't have special talents, I'm just passionate about curiosity. At the beginning of the discourse, I was telling you that everything started during university. I could tell you that Quasar development could be a motivation for the young generation. When the young people see products from Quasar development, they could be motivated to innovate and explore this area. If you need more details on the products or services from Quasar development, you can access our site, quasar-development.com. Thank you. Thank you very much, Mr. Gritco, for this interactive presentation of Quasar development. We know that the company also has applications based on AI, and I would like to ask you what are the emerging trends in the use of artificial intelligence in automotive? AI is already integrated in the automotive industry, but the rhythm of integration is slower than in other industry, given the fact that the automotive industry is related, first of all, to passenger safety. In Quasar development, we are only working with vocal or commands, and we are trying to expand this to the healthcare system. I think this is a good idea to or opportunity to expand your activity in Moldova Embedded Conference. We are continuing with the intervention from Emanuel Botezat, Head of Application System and Software Engineering in the cluster for power electronics in Vitesco. Mr. Botezat has a 5-year experience in the software development area and 4 years in leading software development teams. His current position is that of coordinating teams that are developing software for traction inverters and DC-DC inverters. If there's something that I pronounced incorrectly, please tell us.
Thank you for the introduction. Thank you for inviting us to take part in this first edition of the conference. I am Emanuel Botezat. As Elena said, we represent company Vitesco Technologies, and today I want to tell you some of the elements maybe that my previous speakers mentioned, but which are integrated in the process. I'd like to tell you about what the development process means and why should we use the development processes for developing the embedded applications. Let's try to work with the monitor with the screen at the same side at the same time. So let me tell a little bit about Vitesco Technologies. First, under the Vitesco Technology brand, we've been working for a few years recently. Vitesco is the former powertrain from Continental Department. And in the recent years, we've been rebranded from Continental to Vitesco Technologies. Our purpose is to develop a new idea, a new company which has the main idea of electrification, electronics, and develop components for vehicles which are affordable. Our company's mission is to provide the mobility solutions, clean mobility. We want to contribute to low CO2 emissions. And all these things are done together with our colleagues from the company. And they have the three values: being passionate, partnering, and pioneering. And I also need to let you know that our colleagues develop innovating solutions. We are teams that are dedicated to develop solutions for the vehicles I mentioned. Our goal is to deliver these solutions while considering the costs that we might incur for the production and, of course, to fit in the timelines the clients want for this. For the partnering side, you'll see in the next slide, you'll see that we conclude partnerships with customers, but also my colleagues cooperate a lot in developing these solutions. And from the pioneering perspective, you should know that the Vitesco Technologies has an innovation department. We are doing researches and developing new solutions in this sector. Very briefly about the footprint of our organization. Vitesco Technologies is present in more than 50 locations or around 50 locations in the world with more than 35 employees globally, and our portfolio includes components for electric vehicles, hybrid vehicles, but you will find also components for standard vehicles like internal combustion vehicles. Our headquarters we are present in different countries in Europe, and if we talk about Romania, there are four locations with more than 2,000 employees only in the field of research and development in Sibiu, Timișoara, and Iași. In Brașov, we produce ICUs for electrification, and my colleagues mentioned yesterday about the high voltage inverters produced. And maybe you wondered why do we have these locations for this specific product? Because there is a footprint for the development of this product in Romania. We have drivetrains, differentiated power systems in Sibiu. Those from Timișoara focus on developing ICUs for battery management systems, for high voltage boxes that might include integrate DC-DCs, converters, or even inverters. And the specific for the Iași facility is to develop solutions of high voltage DC-DC, low voltage DC-DC 48 volt standard, inverters for traction inverters, and inverters for belt starter generation. I was saying that in terms of partnering, we have concluded the clear partnerships in relation to raw material supply for components that we use in producing our ICs. And an example is the one with the gun systems or Infineon partnerships that help us control the time for our benefit, and it makes sure that we have always the raw material for the ICU's production. Um, if to talk about partnerships with the customers, because that's the focus of my presentation today, the partnership with the Renault Group helps us develop new technologies for possibly the largest BEV manufacturers. We cooperate with the colleagues from AROBS in the development of ICBC for CBC for Renault, different other softwares. And maybe I would make you curious if I invite you to follow the launch of the new module where we will install the PCBC model. And this is the first vehicle produced by Renault, which has a support in the form of a baguette, this French type of bread. Well, our organization continues to develop after we've been listed on the stock exchange in 2021. In 2023, we received an offer from the heads of the organization to purchase the major share package, and for the middle of May, we've received the approval of the board members from Vitesco to continue the merger. What you shall know is that the new company will have a new division called e-mobility, and the staff of this department will continue focusing on the aforementioned elements. And this division will use also the capability of the leaders to integrate the systems and maybe to develop low cost products but with higher speed and shorter time of development. This was about Vitesco technologies. Now I'd like to go to the technical part of my intervention. Yesterday I was telling about electrification platforms that we currently have in our sector. Some continue to have internal combustion engines, 48 volt mild hybrid, plug-in hybrid, or battery electric vehicle. This might give electrification solutions. And we have this BEV platform, fully electric vehicles, for which Vitesco has some solutions to offer also. those 9 products that you can see on this slide include software solutions. And if it is to think about how Vitesco Technologies develops softwares, my first response that comes to my mind is that of the head of the division of electrification, and this says by project execution, meaning that we have a plan that we need to comply with whilst respecting some steps of implementation. And if to compare the software development could be compared to a Lego. As of today, we have a lot of software elements in a software application. Maybe it's more than 30 or 40 software components, which in their turn include a lot of elements, components, files, and other information. We buy software solutions from other suppliers. Maybe if we think about the Vector, Electrogrid, and other software solution suppliers for our elements for our company, we need to integrate software solutions from customers. And in the partnership with Renault, we integrate the algorithm of engine control from Renault company. So we need to find an appropriate solution to integrate that respective algorithm. And Lego has instruction manual. First, when we receive the pieces, we will have some bags with the pieces and instruction manual. So basically, what we do is to follow the instructions in the manual. And today, I'd like to tell you briefly about frameworks to develop softwares. I've chosen 3 of these. Any of these has developed in time, and if today we develop a methodology of software development, there's so many and diverse elements methods that we might not have enough time in a day to discuss about this. Why did I choose these 3 ones? Because these are strongly related to the way we're developing softwares. Maybe this is typical for this more companies. The first method is prototyping. Such a process is used typically when the innovation department wants to try a new concept. We have a basic requirement set that we want to validate. The solution is developed, so we test it and we understand if it functions or not. Well, obviously, such a software solution could not be industrialized, could not be included in a vehicle without being tested. There's very few tests that we do in terms of prototyping of software. And what I recall now is the one related to the Chi software development for the hard blocks validation. Waterfall development. Many of you may know about this, including with this V cycle, the other side that ensures the continuation of the process. The waterfall process actually is quite a simple process with 5 simple steps to follow. In this process, every step, one developer will develop different uh, products. For example, for the requirements, we need to develop requirements for our developers to review them, to make them very clear for the developers and the testers. For the design stage, the software engineers have to develop architectural elements, be it to design, to model, or draw ports that we need information to be used for the development of some functionalities, or maybe to decide from dynamics point of view about elements that should be included in the functions that are to be created. At the implementation stage, we might find it the most pleasant one because the developers create different files that we need to work with. We will find an file XMLA that I will talk about at the end. And for the verification stage, next we need to check that what we've developed so far is correct. We do unitary tests, integration, or embedding tests. We check that everything works correctly. And within Vitesco Technologies, we have teams dedicated to check the software system requirements or any other type of requirements. And these are automatized as testing elements. We use them as hardware in the loop, software in the loop methods or processes, and as for the system testing, we use as much as possible the integration system that we have in the car. The last stage is the maintenance, the one in which we want to develop back fixes. We look at what problems are identified in the process. If it's about the software, we do an update. If we are not in a tunnel and we manage to do this update, it's okay. But if the problems are of a different nature, we might have a so-called recall process. Maybe you've heard about this recall campaigns when hundreds of vehicles are brought to car services for the recall process. And these are meant to avoid problems or issues that might appear in the end. And the spiral development I want to talk about, we might find this element in other methodologies. And it was transformed. It might be found under the form of Scrum, Agile. So, it has also cycles. Every cycle intends to implement a piece or a part of the software that we need to deliver in the end as a product. For every beginning of a spiral, we will have a stage and increment that we want to develop, to build. Steps are inspired from the first two processes, waterfall and prototyping. And I'd say that difference to be noted here is that there is a fourth step when we plan the next cycle. We want to understand what has functioned, what has not, to understand what is the current situation. And I think that Agile is using a lot this development process. We've heard about standards, ISO, ASPICE, and a little bit AutoSAR. I would like to let you know that there is this specific architecture, Open AutoSAR Automotive, Open System Architecture. And the goal of the architecture we see in this slide is for these blocks to be able to be changed with the most minimum effort possible. We want to have this change fast and to avoid the hacking the controllers if it's possible. In the slide, we can find this application layer architecture. And the solution that I want to present today, the solution that we have implemented for the CDC element using the AutoSAR architecture, relates to the protection of an ICU. And software solutions should always ensure protection at different levels, 1 or 2, safety level 1, safety level 2. And the way in which we develop these software solutions, or these components, if you like to call them so, is in compliance with the standards, or should be compliant with the standards and development processes. For example, we have a protection component involved. If we want to verify, to check that we have the voltage of our BCVC in a specific range, we will look at this component, and this should communicate with the rest of the ICUs. will need permission from the FIMF Fed inhibition module. We will need different diagnostics to be done. Obviously, it will communicate on the same layer of application with mode manager of the vehicle in order to get to the error, identification error, and to tell about the reason for the error. And on the right side, we can see that we always supposed to have inputs by customer-specific adaptation. We have a type CDD layer, have a generic solution, and together with the inputs from the mode manager and other from the journal on the slide, we need to have a hardware that converts energy from high voltage to low voltage. And I also wanted to mention that in Vitesco technology, we have a software for software development solutions, which has a collection of features which might be used for several products or several versions of projects. And this increases continuously. There are different development strategies for the solutions. There might be a generated solution by MATLAB, target link, or manually developed solutions. And in our application software department, basically we need to adjust this solution to the needs of the customers and the projects we are developing, to focus on these customer specific adoptions with everything that refers to the customization and adaptation of the process. I also want to mention about the way the students could apply their knowledge or to learn this knowledge about AutoSAR development of software and standards. In Yash, we have teaching labs, which might be similar to the ones from AROBS. I know that Andrei Bragarenko had at a specific moment in time a lab here which was dedicated for teaching. We invite the students to take part in these teaching labs in the development of software solutions. And if they're not passionate about software solutions, they might take part in hardware solutions development labs. And we have other colleagues, including Marius from hardware engineering. They will have to develop, in that case, a small DC-DC. I think that's all from my side. Thank you very much for your presentation. And I'd like to conclude the discussions in this panel with the presentation of Mr. Gabriel Manole, founder of Nouveaux company. He will talk about software-defined vehicles. Please. Thank you very much for your invitation. I'm really glad to be with you today. I will start by using a joke, and I hope my panel colleagues will not be sad. I heard that when you come with a PowerPoint, you have no power and you have no point. So I've been working for 20 years in automotive in embedded sector. I worked with AutoSAR starting from version 1.1, and last year I published an article in the anniversary brochure of AutoSAR Consortium, which resumed all this journey. And for me, actually, this journey means that I started from basic software, from a software that was very simple. And for the last 20 years, the vehicle transformed from a product that was mainly mechanical to a product that is defined by software. That is my topic to raise. I will talk about how my company dealt with this. I founded an advisory company called Nouveaux, and starting from May from this month, I'm also country manager for Indego company, Romania. We in the Indego company, we're a company focused on mechanics and optics, and they want to add a very strong software component. That's why I joined them, and together with my colleagues from Poland, we will develop a department that will solve such issues. So I walk the talk, and today I will tell you several things about transformation and the future paths, the future journeys of software-defined vehicles. And I really hope that after this short introduction, you keep an interesting new thing that you find out about the cars. The first thing I'd like to bring to your attention is that vehicles, the cars are sold based on a different type of marketing. Maybe you remember that a Lamborghini used to be sold based on its design and the power of its engine, how fast it reached to 100 kilometers per hour, about 3 seconds. But now we have a new car manufactured by Xiaomi, which is basically a manufacturer of appliances and phones. And this new car reaches to 100 kilometers per hour in 2.7 seconds. But this is sold so fast, not only due to his speed, but due to its comfort, his interesting design aspect. And you should think that such a car was developed in a cycle which took less than 3 years. So when you think about this new car, about a new car like a Volkswagen or Mercedes, this used to have longer development cycles. So how did the Xiaomi company manage to do this? They took their experience from the ecosystem, developing embedded ecosystems from phones, TVs, or other appliances, and they developed this car in a partnership with BYD, a Chinese manufacturer, and they manufactured the car. They already mature or used parts are already reused, and the strong points of a Xiaomi car is the integration, the compatibility with the phone, and digital twin, our digital window. Maybe feel very comfortable when you get in the car and you can continue listening to the podcast you used to listen before that by your headphones, or you can take the podcast you listen in the morning on the laptop. So you can pay with those elements you already have on your accounts to cross, for example, to pay for crossing the bridge on Danube at Vitesco, in the Vitesco region. So this is how the flexibility, manageability of the car continues, and the comfort is ensured. The car is and will be thought in order to integrate mobility from one end to another, and it will not be just a simple product. I've just mentioned about the mobility, and if we talk about mobility, this is an important thing for the new society. When we look at the way the society develops, it's two accelerated trends. One is to move from rural areas to urban areas, but at least in Romania and Europe, we can look that big cities became even bigger, and rural areas or less populated became even less populated. Agriculture is done by using drones, by using automatized tractors with a lot of automated processes, less human presence. So everybody goes to big cities, the highest urban agglomerations, and the biggest ones, the largest ones, are in Asia. And in that case, we should use cars or have our own or rent a car, or we might have mobility elements like scooter, tram, bus, autobus, and these elements will be all part of the ecosystem. Recently, I've traveled with my son to Milano, and we had the choice how to travel around the city. We had options for metro, or the subway, tram, or bicycles or scooters, bus to the uh, airport, and the plane. So this helped me to use my phone in looking and choosing different things, and it might even have helped better if we had better options to be compatible with this aspect in one single item. And several things that we need to think about for the long term is that we will want to have updates on our phone, like on the phone. We will not want to have our cars staying at the condition from 10 years ago. One thing that relates here is the subject of Razvan Coban. This will imply cyber security because a car that is not safe can be stolen. And the most expensive the car is, the most important for us will be to update the cybersecurity system. The idea that what is developed now, the features based on AI or models which are trained and can be sent directly to the car to process information or to streamline, to optimize what is there, these would be needed to be updated in the car. So it's important for a car to be able to be updated and the software to be developed, like Emanuel said, in line with the process that is able or can be updated rapidly. And if we think that, for example, we have yesterday and today a hackathon, the students will show the first phase of the product. But to have the final product, we need different phases. We need to have a slide easily changeable when we have different updates. So we don't want these elements to become bureaucratic. These things are done to generate enough information so that updates lead to safe changes. I would not know for an update to just disrupt my phone. Obviously, this uh, cannot happen in the car. And we know also that the new features will need to replace or the old ones, or to replace the new ones, because I would not to them to lose the functions.
If we add ADAS functions, which are very important, I want to still keep the ones that were running. I don't want the previous one to be less and less functional. And another thing that we should take into account, although it seems that the calculation power is unlimited, we need to understand that the applications need to be optimized. We are discussing about embedded and the calculation power. And this has two dimensions. So what we have used needs to last for 10, 15 years. We cannot upgrade it. And it uses electricity. And therefore, there's an issue of consumption and sustainability. Yesterday, you've had a panel discussing about energy. The way we design the software for a car influences energy consumption. There are apps that take a lot of energy and applications that are optimized. We cannot bring new hardware to the car unless we have additional costs. And we always need to update these apps, being aware that there are limitations for resources. This is something that we need to take into account for everything we are doing. We don't have enough water, we don't have enough renewables. China has solar panels for the next 5 years, but I wonder what happens when we need to replace everything. We have green energy when we have wind and sun. Otherwise, it's more difficult to generate energy. And all this needs to be used in moderation. Software is not just about hype. I want the car to function well in 5 years, 10 years, 15 years also. And one can think about the way our parents and grandparents used to wear clothes. Now we are changing clothes very often and we generate a lot of waste. They used to wear a suit for 5, 10 years. It was relatively on fashion. We didn't have that pressure from fashion, and we didn't generate waste. If you are thinking about how houses used to look like, they didn't have a lot of furniture, they didn't have a lot of clothes. And the car means simplifying these concepts, integrating many things in one, having updates, and making sure that cybersecurity is well managed so that our data, our cars cannot be accessed. This was my speech for today. I hope that you have remembered or found out something new, something interesting, and I'm looking forward to meeting you again. Thank you, Mr. Manole, and I would like to thank the other panelists that have tackled an important topic, cybersecurity and in automotive. Please applaud them again.